Okay, this is a really important question I want to go through for you. Two forces, F1 and F2, of magnitude 60 and 70 pounds, respectively, act on an object. The direction of force 1 is south 40 east, and force 2 south 40 west. Okay, so find the direction of the resultant force. So let's draw what's going on here. So here we go. We're going to have the first vector, 60 pounds, south 40 east. So that's about like that. It's 60 pounds, and this is north, south, east, west. So that's south, but 40 east. This is 40 degrees to the east. So this is south, 40 east. And then the other vector is 70 pounds, south 40 west. So this direction, and a little bit longer, that's probably too much. A little bit longer, and it's 70 pounds, 40 degrees this way, south 40 west. There we go. Okay, so now there's 3 steps in this process. Step 1. You've got to change the vectors to I, J. Step 2. Add the 2 vectors to find the resultant. Step 3. Change the resultant back to an angle. There's our 3 steps. Okay. So first step is we got to change these vectors to ij. So that means we've got to find out their actual angle. So this is really important. You've got to find out their actual angle. What do I mean actual, or direction angle it's called? That means from 0 degrees. Right here they call it a direction angle. From 0 degrees. So that blue vector, for example, how far is it from 0? Like all the way around. From 0 to that vector. How is that? Well, that's 270s down here, right? 90 straight up, 180 over here. So that's more than 270. So that's 270 plus 40. That's 310 degrees. So that vector, that blue vector, then, remember how this works, is 60 cosine of 310 degrees I plus 60 sine 310 degrees J. Remember, you put the magnitude times the cosine of the angle I and the magnitude times the sine of the angle J. Makes sense that cosine, all semester long, cosine has been for x, right and left. So it makes sense that would go with I, which means right and left. And sine has been up and down. That goes with J. J is up and down vector movement. Okay, so that makes sense. Now, let's do the other vector. How far from 0 to the orange 70 vector? Well, that's less than 270, right? That's back from 270 by 40. So that's going to be 270 minus 40, isn't it? So that's going to equal 230 degrees for the orange vector. So that's going to be, bring that over here, that's going to be 70 cosine 230 degrees I plus 70 sine 230 degrees J. So there we go. There's the first step. Change the vectors to ij using their actual angles from 0 degrees. Now, we need to add them up and get the resultant vector. This is done on your calculator. Crank it out. I'll do it on my calculator right now also. Make sure you're in degree mode. And I'm getting negative 6.428i. The next one. Negative 99.586. 586. j. So this is the resultant vector. Step 2. Check 1, check 2, step 2. We found the resultant. Now comes the real hard part. Most people can get to there okay. Here's where a lot of students are confused. How do we change that resultant to an angle? Change a vector to an angle theta. How do you find the angle? Math Excel does a bad job of explaining this on the Show Me an Example. And so I need to give you the whole process here. So step 1. Let me encourage you, don't skip steps. This is where most people will miss this on the exam. So step 1, draw the vector to find the quadrant. You really got to draw it. So I'm going to draw the vector, to find the quadrant. So what do I mean draw the vector? I mean take this resultant vector here. Let me put it over here so where we can see it. The resultant vector is negative 6.4, 28i minus 99.586j. So that means it's what? Left and down. It's left a little, down a bunch, isn't it? Back 6. Remember, the I is right, left, so negative is left. And the j is up, down, so negative is down. Down 99, whatever. So that means this vector is down and left. It's in the third quadrant. Down and left. That's really important. That makes sense if you go back to the diagram, right? If we have an object right here, like a box sitting in the middle of a warehouse, and we're pulling with the blue rope down in right 60 and a rope down in the orange rope down in left 70, what's the result of those two? Well, it's going to go down and a little bit to the left, isn't it? That's going to be the resultant. Makes sense because the orange rope pulls a little stronger. It'll go a little to the left. Both are pulling down, so it'll go mainly down, south, but a little bit to the left because the orange 70 is bigger than the blue 60. So it makes sense that the resultant vector is in the third quadrant. So down and to the left, there is the resultant vector. Okay? So you got to draw that. Don't skip that step. Number 2. Now do the tangent inverse. Most people want to dive right in, but watch this. This is different than Math Excel because they don't do a good job in covering this. Plus, you need the plus version of j over the plus version of I. You got to make them positive. Why? Why can't, well, here, let me just keep going and I'll explain the why in a minute. Tangent, so I got to take the j's positive version, 99.586, over the i's positive version, positive 6.428, like that. Hit the buttons on your calculator. And I'm getting 86.307 degrees. Now that's not my answer. A lot of people get that and they go, okay, there's my answer. Go up and let's find it. 86. It's not there. It's not done yet. This is the part that you really need to pay attention to that most people miss. This is a reference angle. It's not the actual answer yet, but it'll refer us to the answer. It's a reference angle. What do you mean reference angle? It's how far to the nearest x-axis. That's what it is. What am I talking about? It's a good time to review reference angles. It's been a while. So if you go back up here, if you go back up here and you look at your resultant vector, here is the positive, this is the x-axis, right? There's the positive side of the x-axis. Here's the negative side. There's two sides to the x-axis, the positive side and the negative side. This resultant vector, is he closer to the negative side or is he closer to the positive side of the x-axis? He's closer to the negative side. Well, then that's what this 86 is. This 86 point, what is it, 307, is right there. It's how far from him to the nearest side. Yeah, I should say that. How far to the nearest side of the x-axis. How far to the nearest side of the x-axis? 86.307. That's what it's telling you. That's what it's telling you. So how do you get your actual final, everything said and done answer then? You've got to go from 0 all the way to the resultant vector. Remember, actual angles of any vector are from 0. Well, how am I going to do that? Well, that's past 180. It didn't quite make it to 270, but it's 180 plus, so the actual angle, the true angle of that resultant vector is 180 plus the 86.307. The true angle, what they really call that the direction angle. I should write it that way. The direction angle. It tells you the real direction it's going. Add those together, you get 266.3. I just want you to round to one spot. 266.3. There it is, 266.3. Do you see that? That's how you actually do the problem. So now you might want to, gosh, Mr. Aaron, do you really have to do all this stuff? You do. I know Math Excel did it quicker sometimes, and you might have sometimes done it quicker and get away with it. But those methods will not always work. I promise if there was an easier way, I'd show it to you. Just doing tangent inverse and not worrying about all these details will not always work. It'll work if the vector's in the first quadrant, but it won't work for other quadrants. Why not? Why all this monkey business? It's because of the weird stuff, again, up here with the tangent, or actually I didn't tell you, did I? Let me go over here. It's because of the weird stuff. Remember that tangent and sine inverse and tangent inverse only give answers in those two quadrants back from chapter 2, remember? And cosine inverse only gives answers in the first and second quadrant. It's because of all that weird stuff that you can't just do tangent inverse and boom, assume you've got the right answer. It can only tell you about these two quadrants. So to get the overall real answer, you've got to start by drawing it, find out what quadrant it's truly in, change both the top and bottom numbers to plus. Why? Because that gets you a positive answer in the first quadrant, and then you use that because that tells you exactly how far away it is from the x-axis, and then you just find how far away that is from the x-axis in the true quadrant it's in, and that meant that we go from 0, 180 plus 86, and then you get your real answer. That's what you have to do to reliably get this. So this is for all the problems in which you want to get an angle. When you have an ij vector and you want to get an angle theta. There's at least 2 or 3 of those on the exam. Very important that you know this process. Step 1, draw the vector to find the quadrant. Do tangent inverse of both positive. Get a positive answer. Know that's a reference angle. That's how far to the nearest side of the x-axis. You might wonder, what do you mean by nearest side? Well, if the vector was over here, for example, then the positive x-axis would be the nearest side, wouldn't it? So it just depends where the vector is. Our vector was on the left, so it's closer to the negative side of the x-axis. That's how we do that. You gotta practice that way. So for example, let me do one more of these real quick. What if we had negative 3i, plus 3i minus 2j? Let's find the angle theta. Well, you'd have to draw it first. It's right and down, right? Plus 3 down 2. Probably went a little farther. So there would be the vector. Fourth, of course, step 1, draw it. Step 2, do tangent inverse of positive 2 over positive, right? It's the positive j over the positive. It's always y over x. Tangent is always y over x, sine over cosine. So do tangent inverse now. Tangent inverse, 2 divided by 3. I'm getting 33.690 degrees. And then realize that's a reference. That's reference. It's from the nearest side of the x-axis. What's the nearest side of the x-axis? Well, in this case, it's the positive x-axis, right? It's nearer that than it is to the negative x-axis. This one's closer to the positive x-axis. So let me get rid of these 3's and whoops, this stuff. So that would be telling us this angle here is the 33.690 degrees. It's how far to the nearest side of the x-axis. Okay, great. So what? How do we find the actual direction angle, what we've been trying to find from the beginning? Well, that's from 0. So starting from 0 degrees all the way to that one, how are you going to get it? Here's 270. Yeah, it's more than 270, but notice the black right here doesn't touch the 270. What does it touch? It touches the 360, doesn't it? So it'd be easier to just take 360 and subtract 33.690. Do you see how it's just a little bit shy of 360? So always use whatever the reference angle is touching. So that'll be the good way to do that. So 360 minus that, and we get the actual angle, 326.310 degrees. That's how you find actual angles from an IJ vector.